How do we apply the sum and difference formulas? We learned them today. How do we apply them? So, the first thing is we can calculate angles that we didn't already know before. And this is not true of all angles. There's a reason I chose 15 degrees, not 14 degrees. But the basic idea is if we can figure out a way to write this as a sum or a difference of two angles, we can rewrite it. So, for example, we know that 15 degrees is 45 degrees minus 30 degrees. And we know everything we need to know about 45 degrees. We know everything we need to know about 30 degrees. So if we apply these two things together, it's just a matter of remembering the formula. So the formula for the difference is sine of the first angle, cosine of the second angle, minus cosine of the first angle, sine of the second angle. And if I got that wrong, that's fine. It's just changing the order of these two by the commutative property or changing the order of these two by the commutative property. It's not that I just randomly picked them. It's that it doesn't matter whether you say cosine u sine v or sine u cosine v. Okay, now we plug in 45 for u and 30 for v. So sine of 45 degrees, cosine of 30 degrees, cosine of 45 degrees, sine of 30 degrees. So sine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Cosine is square root of 2 over 2. Sine is square root of 1 over 2. So just 1. And then we get square root of 6 minus square root of 2 all over 4 because they have a common denominator of 4. So that is the sine of 15 degrees. Something we didn't know before. Calculate this. It was very obvious to say that 15 degrees was 45 minus 30. But what are the angles that we know? Well, we know pi over 6. We know pi over 3. And we know pi over 4. So pi over 6 is, well, we get a common denominator. That's 2 pi over 12. We want to figure out what all of these are as something pi over 12. If we multiply by 4 over 4, we get 4 pi over 12 and 3 pi over 12. So how can we combine these two? Well, if we take these two, they add up to what we're looking for. So this is sine of pi over 6 plus pi over 4. And if you preferred to put them in the other order, that would be fine. It would still work just as well. So what was our sum formula for sine? Well, it was sine of u, cosine of v, plus cosine of u, sine of v. So u is pi over 6, cosine pi over 4, cosine pi over 6, sine pi over 4. Okay, now we have sine pi over 6, that is 1/2 square root of 2 over 2. We have square root of 3 over 2, and what is this? Square root of 2 over 2. So this is very similar to the previous one. We have square root of 2 over 4 plus square root of 6 over 4, which is square root of 2 plus square root of 6 over 4. Very close to our previous answer. This had subtraction. This is addition. We can do this with variables as well. So here it's very obvious what our u and v are. We're taking u as x, v is pi. So what was our formula for cosine as a difference? Cosine of u, cosine of v, plus sine of u, sine of v. So cosine of x, cosine of pi. Sine of x, sine of pi. Now, let's see. We don't know what cosine of x or sine of x is, but we know what cosine of pi is. Cosine of pi is -1. Sine of pi is 0. So this whole thing is going to become 0. And this will be cosine of x times -1 plus, I'm going to write it out anyway, sine of x times 0. So this is 0 plus negative cosine of x. So this equals negative cosine of x. And that's what we figured out before when we said, okay, if I take this, shift it right by half a period, it will become the same as the reflection. But here's an algebraic way of showing it. And this one is clearly more confusing, but we have a u and a v written out. So now it's a matter of what's the formula? Sine of u cosine of v minus cosine of v sine of u. So let's plug these in. And this is where things get a little ugly. Oh, I'm sorry, I wrote this out wrong. This is cosine of u and sine of v. That makes more sense. Cosine of u would be cosine of arc cosine of 2x, sine of arc cosine of 1. Okay. If you need to check the substitution in there, that's fair. It's just a matter of tracking things. So this is u is here. This is u is here. This is v there and there and there and there. So now we have to figure out what each of these are. I like to start with the ones that are obvious. Cosine of arc cosine is 1. Cosine of arc cosine of 2x is 2x times this. This, of course, is times that. So what is sine of arc cosine of 2x? Well, this is something that we learned how to do in the last unit. What we'll do is we'll draw a triangle, and the adjacent over the hypotenuse will be 2x over 1. We can use the Pythagorean theorem to find out that this side is 1 minus 4x squared. So then sine will be opposite, square root of 1 minus 4x squared over the hypotenuse. So this is square root of 1 minus 4x squared. If that was confusing, go back to some of the videos from the previous unit, Unit 4, and you'll see what I'm talking about. Here we have, this is arc cosine of 1. Arc cosine of 1 is actually 0. If we look at our unit circle, cosine is 1 there, and that's where sine is 0. So this whole thing becomes 0. So now we have square root of 1 minus 4x squared times 1. Well, that's just the same radical. This is 0. So we are left with our answer as square root of 1 minus 4x squared. Please don't try to square root those two things separately. You cannot do that. That's how we apply our sum and difference formulas.